came from the train trestle, the same area that the other 4 mammoth.
Okay.
And there are 4 more complete teeth and an awful lot of plates. Maybe 50 to 75 plates.
Very, very nice. I would guess that this must be one of the, what shall we say, probably mid molars, not the last, and perhaps, well, one of the progressive mammoths with plenty of, as you say, many plates and nice complex wrinkles on the enamel. It's beautiful.
On this side of it, when it's bubbling out, is this just newly erupting or is that just worn away?
That's wearing away, and it's sort of an interesting oblique way they progress up through the crypt, and then new material forming at the front end, and of course wearing, and then the deeper part of the tooth toward the rear. So this, for example, might be a right lower. The uppers tend to wear more convex and the lowers more concave. And then, so this is the front of the mouth, and then pieces of tooth, or certainly the previous milk premolars, are already spat out, and you get this sort of odd 1 or 2 at a time succession that elephants have, quite unlike us, where we just add the whole set of teeth.
Right.
These guys are spitting out, so essentially they got 1 in the mouth, each jaw quadrant at a time. And I would guess this is about the first molar. It doesn't look quite big enough. They keep getting bigger. M2, M3 was really large. But it's diagnostic, that's for sure.
How many molars with a mammoth jaw?
They
Say
go
the lower
through
jaw, do we, at any one time in the jaw, do you have 2?
You only 2 max, and sometimes just 1. And of course they spend the second half of their life just grinding away on that last big molar, which could last from age 40 to, terminal age 80 or 100.
Wow. They lived that long.
Yeah.
Lifespan was
based
80, 100 years.
Mainly on what living elephants do. The African can live 80 to 100 years. And so anyhow, these are essentially elephant-like mammoth groups. If anything, the mammoths are more progressive than the living elephants. It's kind of interesting. Apparently, in terms of complexity of teeth and even body size, and so we think of them as a sort of super progressive group that unfortunately got terminated.
When you say progressive in paleontology, you're meaning the term progressive, meaning they were more adapt perhaps to their environment than our elephants are to our environment?
Exactly. And it really is it's a treacherous word to use because in fact you're quite proper to ask for a definition, but it usually means that if the trend is towards, let's say, more plates in the teeth, then more progressive is more plates, and you're sort of extending trends that you see in nature and reading into that perhaps some adaptation. For example, the number of plates and the compression of plates we assume is an adaptation for grinding coarse grass or tundra vegetation. And the ultimate record in terms of compression and plate numbers goes to the woolly mammoths that lived in tundra.
Any difference between the lower and the upper teeth as far as, well, when we pulled the set of 4 up, in my set that I have a set of 4 at home from Venice, they're completely different teeth, the uppers and the lowers. The lowers are a lot less bulky, for one thing. They're smaller teeth.
That's right.
The uppers are huge.
That's right.
Almost triangular shaped with their root system, if it's intact. And is there a difference in the way the plates lie with uppers and lowers and the grinding technique? Are the lowers spaced more widely and the uppers, or vice versa?
They ultimately have about the same spacing, which actually makes sense. If you count plates, they come out about the same. Equivalent upper and lowers have about the same plate counts. And if you think about it as a grinding mill, they almost have to have, sort of equivalent chopping edges passing by one another. But the uppers are quite different. They are wider, and a little bit more straight, whereas these lowers are slanted a little bit more forward. So they meet at a funny angle and essentially grind across one another in a
That was my next
cutting
question
manner.
about that angle. Some
Yeah.
teeth come out, some lowers come out almost straight up and down sometimes.
And the fact that the uppers are a little wider than the equivalent lowers is where you end up, in effect, getting this convex above, concave below. And it almost seems like the lowers do have to wear faster because there's less of them in cross-section. So it's an amazing mill. And I suppose what happens to compensate for faster concave wear is that the lowers may be a little deeper. I'm pretty well convinced that's pretty hard to measure, that they have a little more height or depth to them compared to the uppers.
The lowers have more depth.
More depth, and the uppers are sort of more, bulky. They're definitely wider. But it's very hard to measure because each one is a sort of interesting triangle of growth.
You don't think of a tooth. The people that have seen a tooth, and I usually take an upper if I'm going to display a mammoth tooth, can't imagine it's one tooth. They think it's a tooth in a jaw. All of that can't be tooth material.
Right.
You begin to show them the root system that's coming down, at an angle in there. Like, I still don't understand. We have to basically take that now, angle it up in the skull to support it. I can understand the heavier teeth being in the skull, all that bone structure supporting it, whereas the other teeth in the jaw are not going to be able to be that bulky. You'd have this tremendous jaw.
That's right.
Hanging off
It's
the
difficult. It's really difficult to conceive of the whole operation. Even dentists are sometimes amazed. I mean, they're used to dealing with things that have a simple number of flat cusps and, of course, a simple number of roots.
Now,
whereas elephants are amazing.
Compared to a mammoth or mammothus, now we go into the mastodon, the species of mastodon. I'm not particularly sure of what specific species the tooth that has come up and the teeth that may be coming up from the Hokkaido site are. Why are the mammoth and the mastodon teeth so different? Why?
It's very clear that in terms of history that those two groups have been separate for a long, long time. Almost from the beginning, way back beginning of the age of mammals in Africa, these two groups show up right from the beginning in areas around the pyramids and down the Nile. In 50-million-year-old rocks we find a kind of primitive mastodon and a kind of primitive, not strictly elephant, but predecessor of elephant called gomphotheres. And the two have gone their own ways for the whole Cenozoic era. And I think also, besides the historical angle, there's an adaptive angle where they're filling very different niches or lifeways. The mastodons are basically conservative, low-crowned dentitions, adapted probably for chewing fairly light forms of vegetable matter, leaves and such, browsers in bulk. And then the group that led to elephants becoming more and more specialized for fancy, tall, crowned teeth, complex enamel wrinkling, eventually the extreme platy, tall teeth that we think of as elephant and mammoth. But their whole history for 50 million years was trending toward grazing on coarser and coarser vegetation. Grasslands begin to show up in the middle of that history, and they adapt ever more progressively.
So as much as a mastodon looks elephantine, are we correct in assuming that we shouldn't call it an elephantine?
That's right. That's right. I revert to the slightly technical term, but I kind of like it, of Proboscidea, and the whole order that includes both groups are called the Proboscidea, referring to their long schnoz, and they share those adaptations.
Share those traits and then not others. Certainly.
That's right. That's right. The tusks and the big trunk are very much the hallmark of Proboscidea from the very origins